Our dream is to contribute and solve the world energy problem. As you know, the world energy consumption is increasing with rapid growth in population and industrialization. However, we have been consuming already a few times as much oil as we discover, and the oil production is considered to reach a peak in the near future. On the other hand, for the prevention of the global warming, we need to reduce drastically the CO2, carbon dioxide emission from the energy consumption. To address those difficult and complicated problems, we apply the systems and resources within the semi-infinite rock mass at few kilometers deep under your feet. We are currently focusing on methane hydrate and geothermal heat as unconventional sources of energy, and also a technology of CO2 geological storage as a means to prevent global warming. The methane hydrate is expected to be a huge unconventional source of energy, and in Japan, it is actually distributed below deep ocean floor off the coast. The methane hydrate is a compound composed of methane and water molecules. However, it is not a fluid such as oil and gas, but it is ice-like solid. And therefore, some stimulation should be applied to drive its dissociation in the hydrate-bearing formation, and then the resultant methane gas will be collected and produced through a borehole. For enhancement of the stimulation and gas production, we are developing a method to induce and control fluxes around the boreholes based on laboratory experiments and numerical simulations. Nowadays, the global warming is recognized as a crisis. To contain warming, its risk and consequences, the warming should be less than 2 degrees Celsius compared to the early 20th century. To attain this target, CO2 emission should be reduced to the half compared to the 90s until 2050. The required reduction in CO2 emission is huge, as much as a few tens of gigatons per year over the world. And for completing this huge reduction, a technology of CO2 geological storage is expected to play an important role. In this idea, CO2 will be injected and stored permanently in porous formation at a depth below 800 meters. Here the formation should be covered with impermeable seals to inhibit upward migration of CO2. However, it is hard to know in detail the structure of such deep formation, and if the seal contains unexpected permeable pathways such as fault and fractures, then the stored CO2 will leak upward through these pathways. Considering this situation, we are developing a method which can be applied to reduce the medium permeability along the potential permeable pathways with the aid of CO2 itself. I hope you are interested in our research project. I'm looking forward to discussing and answering your questions. Let's think with us what we can do for the future of the Earth.